Okay, so let's take a look at some linear inequalities in two variables, meaning we have two letters like x and y. Remember, go back to grade 9 and understand how we work with inequalities like x is greater than or less than equal to on the number line in grade 9, and then review it in grade 10, domain and range. And this stuff will be a lot more simple to you. I'll keep reminding you of the things necessary that absolutely for to be moved on, and go a little bit quick sometimes. So it says graph the following inequality. Y is greater than x minus 2. So I'm going to skip an appropriate number of lines to do some more work. And then I'm going to graph it below. And so make sure you skip the appropriate number of lines. So if I draw the graph down below, I can draw the graph. And as the English instructions say, I graph the equation y equals x minus 2, treating it like an equal sign. So the equation y equals x minus 2 in the form y equals mx plus b has a y-intercept of negative 2. Now, because it's a greater than or a less than, we use open dots. I'm going to put a rectangle around that. That's a remember that we need. So I'm going to put my y-intercept at negative 2 with an open dot. Then my slope is 1, so up 1 over 1, up 1 over 1, up 1 over 1, both directions, open dots. And, excuse me, I'm going to extend that box. I forgot. In the box, I'm going to say dot, 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 dotted lines. So we do a dotted lines through it. Great. So now we're ready to decide if we're going to shade above or below. And we're going to pick a test point. And that test point we're going to choose is 0, 0. I'm going to identify where 0, 0 is on the graph and call it 0, 0. So a test point, as you can see in the notes. Now, an English instruction in the notes. Choose a point on either side of the line. So we chose 0, 0 because it was on either side of the line. Some people call it the 0, 0 test because you so often choose 0, 0. So 0, 0 is just a nice, easy number to choose. There's an English sentence at the bottom of the page that says, notice, the 0, 0 test only works if 0, 0 is not on the line. If 0, 0 is on the line, we must choose a distinct point that is not on the line, like 5, 0 or 0, 2 or any other point on the graph. Okay, back up. So test point, 0, 0, x and y. I'm going to start by writing the equation down. Y is greater than x minus 2. I'm going to then substitute 0 for x and 0 for y. 0 is greater than 0 minus 2. 0 minus 2 is negative 2. 0 is greater than negative 2. Now, is that a correct statement? Yes. 0 is to the right of negative 2 on the number line, therefore it is greater. So, it's correct. Check mark. We shade the 0, 0 side of the line. If that was incorrect, it would obviously shade not the 0, 0 side, the other side, which we're going to see in the next example off to the right in the notes. But continuing down the page. First of all, I'm just going to identify the point 3, negative 2 in the notes and call it 3, negative 2. And if we were to put in that point, we would have gotten a wrong solution. And we would have shaded the other side. And we're going to make sure that we cover all those exact opposite idiosyncrasies in the next example off to the right. Okay, so I'm just going to shrink that stuff up a bit, write smaller than me, or print off the notes. So I'm going to rewrite the question down below. Y is greater than x minus 2. And no, that was just me writing the equation near the tip of the line because we're always supposed to, or just put an arrow to what it means. So now, let's say, for example, you just got the graph above with no equations. Well, you'd recognize that it's in y equals mx plus b form, so you say y space. Now we know the slope is 1 up 1 over 1, so 1x, and the y-intercept is -2, so minus 2. Then we need to decide if it's greater than or less than, based on the shading above. So we do exactly the same thing as we did before. We do the 0, 0 test. Well, it's called a test point, but just remember the idiosyncrasy. So we put 0 in for y and 0 in for x, and then just say minus 2 because it's still there. Then we think, well, on the right-hand side, 0 minus 2 is -2. 0, 0 minus 2 is -2. So then we think, we shaded the 0, 0 side. We need to make a correct statement, so we completely reverse the last process and put a check mark. Then make a correct statement, and 0 is greater than -2, so we put a greater than sign. Then don't be lazy and just put that sign above it. Rewrite the equation above it. Skip a line with the sign we just figured out and the equation that we knew from y equals mx plus b. Circle your answer. So that's graphing a linear inequality in two variables, deciding whether or not to shade above or below the line by choosing a test point, usually 0, 0. And if it makes a correct statement, we obviously shade the correct side. And that's funny because remember above, I kind of mentioned this point 3, -2. I actually do the algebra in the notes down below where I tested it and it was wrong. And I already read that English sentence down below about the 0, 0 test. So, before we do the example off to the right, we're going to read the English instructions at the absolute far bottom. So, or, we can just say shade above or below the line based on the English instructions off to the right. Replace the word y with shade. The word greater than with above, less than with below. Replace the equation with the line. So, if I want to read this equation at the bottom, big blue circled, I read shade above line. Math is simple when you start to realize it. Okay, so then you don't even have to do the test. You can just look at the graph and go, oh, that's y equals greater than x minus 2. Okay, so that's linear inequalities in two variables. Now, for some reason, we're going to, question off to the right. Okay, so yeah, we got about half. Okay, so let's say, for example, at the top we get the equation x minus y is greater than or equal to 2. Well, there's two ways you can do it, as you can see in the notes. I'll just do the example off to the left to remind you of something necessary. Let's minus x from both sides. So minus y is greater than equal to. Let's put the x first. So negative x minusing x from both sides plus 2. Then we have to divide both sides by -1, carefully dividing each and everything on each side by -1. Negative y divided by -1 is just y. Now we divided both sides by -1, so we have to change the direction of the sign. Less than equal to x minus 2. So again, let's circle that answer. That's a good answer coming from standard form above into slope-intercept form below, just because it's a little bit simpler graphing y equals mx plus b than graphing standard form making a table of values. But remember, if you forget everything, just make a table of values. Okay, so we're going to graph this inequality that we just figured out above. And again, remember, you can instead have done it in a different way. That's funny. The English instructions below are opposite. Be careful with that. That's funny. Okay, pardon me. So, first of all, just like we instructed above, now we're doing less than, equal to, or greater than equal to. Those are closed dots and solid lines. So let's put a rectangle around that to remember that. Then let's graph it. So again, I'm going to graph it down below with some space to do the test point, just because in the future, well, reasons. So let's graph this thing above. Y is less than or equal to x minus 2. Well, look what we have here. A y-intercept of -2 and a slope of up 1 over 1. The exact same graph that we graphed off to the left. Purposes, so that part's easy. You can learn the steps and then apply them to harder questions with the identical steps. So if I were to cheat, I'd know to shade below the line because I could just say shade less than the line. But let's do it properly and choose a test point. Let's choose 0, 0 because the line's not going through 0, 0. Write it down. Write the equation in question. Y is less than or equal to x minus 2. Substitute 0 in for x and 0 in for y. 0 is less than or equal to 0 minus 2. Combine like terms on the right-hand side. 0 is less than or equal to 0 minus 2 is -2. Now, is 0 less than -2? Is 0 to the left of -2 on the number line? No. So gigantic X, and because we did the 0, 0 test, and because 0, 0 is right here, and the test was wrong, we shade not the 0, 0 side. Obviously. So again, the example on the left, it was correct. We shade the correct side. And if we had tested a point not on the correct side, it would have been wrong to tell us to shade the other side. Or we do a test and it's wrong immediately, and we just shade the other side of the test point. Okay, so now let's shrink that up a bunch. So, that's why I wanted to put the 0, 0 test or the test point above the graph, because then I wanted to find the equation from the graph, like we did off to the left, when the test point wouldn't have been in the way. So now let's pretend like we don't have the equation above, we didn't do any of that algebra, we didn't do the test point, and we only see the graph with this shade. Well, we're going to start by saying y space, we know it's y equals mx plus b, so whoa, oh my gosh, okay, excuse me. No, okay, sorry. So I just shrunk the graph above, so the graph paper looks funny now. It was perfect before, so keep that in mind. The slope looks funny now. But the equation of that line had a slope of 1, so 1x, and a y-intercept of -2. Obviously the same equation that was above. Now we could just think shade less than the line and put a less than sign, but let's do it algebraically in case you have to. So again, we're going to do the 0, 0 test. So we're going to put 0 or a test point, and we can do 0, 0 because it's easy. And we're going to put 0 in for y and 0 in for x and solve. The right-hand side, 0 minus 2 is -2. Now this time the 0, 0 test was wrong, so we identify an x, and then we make a wrong statement. And we say less than, and because the line has closed dots and is solid, we say equal to. Then we put the exact sign into the equation 2 lines above, but we write it below. Y is less than or equal to x minus 2. Circle your answer. So that's getting an equation and finding the graph, and getting the graph and finding the equation. Doing the test point every time and understanding what the test point means. If you put the test point in and it's good, you obviously shade that side. And if you put it in and it's bad, you obviously shade the other side. etc. Okay, so those are linear inequalities in two variables. And again, I almost interrupted halfway through the video, but now we're going to get on to just one variable and look at lines and parabolas. And then we're going to get back into two variables in the next section and get back to lines and parabolas and then shade above and below parabolas and combinations of those things. But now, as I said, we're going to get into one variable.